All right, so I received some questions from a couple of you about different examples. So this is from the 1.3, that first night's review packet. The first one was about example 8, where you are asked to work with x squared minus 25. Now, x squared minus 25 is a special type of polynomial called a difference of two squares. You should notice, or you may notice, that x squared minus 25, ooh, that light is in a bad spot, okay, so x squared minus 25, this is a perfect square, and so is this. Now I'm going to talk about two different ways that you could address this problem. Number one, you could look at it just like any other quadratic factoring problem, meaning you could consider that as x squared plus 0x, adding a 0x does not change the value of anything, minus 25. Now I'm looking for two numbers that when I add them together I get 0, and when I multiply them I get negative 25. So that's going to be x plus 5 times x minus 5. But that can also be done via formula. Like I said, this is a special thing called a difference of two squares. And the formula for the difference of two squares is a squared minus b squared equals a plus b times a minus b. So in this problem, you would say, all right, that's x squared minus 25. So a squared is x squared, which means a equals x. B squared is 25, so b equals 5. So now just plugging into that formula, you have x plus 5 times x minus 5. The next question I got was about example 12. And in example 12, we are trying to determine if negative numbers are in the domain of some of these functions. So f of x equals 4x plus 7. You start with all real numbers. And I'm just going to write it down because that ends up being the answer. Do you have a radical? No. Do you have any variables in the denominator? No. So because both of those answers are no, we started with all real numbers. We did not eliminate anything, so our answer is all real numbers. Now in the next one we have f of x equals 1 over x. So x cannot equal 0 because whatever's in the denominator you set not equal to 0. Well, that means that negative infinity up to 0, good. Do not include 0, unioned with 0 to positive infinity. The only number we took out is 0. So the answer to the question, do we have negative numbers? Absolutely. We have all the negative numbers. The only number that we took out was 0. In the last one, f of x equals the square root of x. Whatever is underneath the radical, x must be greater than or equal to 0. So here we start at 0, we go to infinity. Those are all positive numbers, so the answer is no, there are no negative numbers there. Example 13 deals with the idea that you cannot have zeros in your denominator. So if you have f of x equals 1 over x plus 3, you set the denominator not equal to 0. That means that x cannot equal negative 3. So the full domain is just eliminating negative 3. In similar fashion, we've got 1 over x minus 3. We're going to take that denominator, set it not equal to 0. So x cannot equal 3. And so we've got the same idea there. In this one, the problem looks a little different because it has a variable in the numerator. As far as domain goes, we do not care about that numerator at all. So x plus 5 cannot equal 0. X cannot equal negative 5. In this last one, you have f of x equals 2x over x squared minus 4. Now, you take that x squared minus 4, set it not equal to 0. There are two different ways you can get the same answer. X squared minus 4 not equal to 0 means that x squared is not equal to 4. Take the square root of both sides, and x cannot equal. Remember, when you take the square root of something squared, you get that plus or minus 2. The other way you could do that, if you watched earlier in this video, this is a difference of two squares, so that would factor to x plus 2 times x minus 2 not equal to 0. Setting each one of those not equal to 0 separately, we get the same x cannot equal 2 or negative 2 answer. The last question that I got so far was on example 15. So here we are looking at domain when it has to do with radicals. So you have f of x equals the square root of x plus 3. You take whatever is underneath x plus 3, set it greater than or equal to 0, so x must be greater than or equal to negative 3. Since we have the or equal to, we open with a bracket, negative 3, and then we go on forever, so we are at infinity. F of x equals the square root of 4 minus x. Again, 4 minus x greater than or equal to 0. 4 greater than or equal to x. So now x is smaller than 4, so we're going to go from negative infinity up to 4 and include it. Lastly, we have f of x equals the square root of 4x minus 8. We take the 4x minus 8, set it greater than or equal to 0. 4x greater than or equal to 8, x greater than or equal to 2. And so we are going from 2 to infinity. All right, well, I hope those help. Any other questions, please just send me an email.